Hey everybody, welcome back to another fantastic episode of Ready to Die Fighting. I'm Chris. I'm here behind the camera, and today we're going to be doing some more little sketches and talking about outer space a little bit. I really enjoyed the last video where we were talking about all this fun stuff, showing just like the massive scale of our solar system and how we're just tiny little specks of dust. We're smaller than specks of dust, comparatively speaking. And just how fascinating I find that, and how it does all apply to our better understanding of our world and going to make us, just better survivalists, better understanding of nature, building that primitive wisdom that I kind of talked about before. So I'm probably going to make several videos along these lines. At least until you guys tell me that you hate them and don't want to do them, or until my, interest and passion on the topic has subsided. So, let's get into this. We talked about, like I said, the big, grand scale of things, but today I want to focus in a little bit smaller, and just on our sun and earth and moon a little bit, and things that relate a little bit more directly to our experiences here on the surface of Earth. So if you enjoy this, please like and subscribe. Leave a comment and let me know if there's anything you want me to talk about, or if you have any questions, or if you hate these videos and just want me to stick to, the more, commonly talked about things in the prepping and survival, homesteading, all that type of world. Let me know. Or if you love it, let me know that too. It's very helpful to me. Help me help you. Let's get started here. So, this time around, as we discussed before, the sun is the center of our solar system. That's actually why we call it a solar system. It's a system that is built around our sun. Everything revolves around it. Our solar system is kind of defined as this area in space that is under the influence of our sun. That's the simplest way I can think of to define it. So once you get, all of the planets in our system, they're all revolving around our sun. They're affected by the sun's solar wind and its radiation. It gets light and heat from the sun to varying degrees, of course. Some places get a lot more than others, depending on how close you are. But they're all affected, even the furthermost planets. Even once you get way out to the Oort cloud, it is still affected by the sun's gravitational pull and its light and radiation and heat and all that. It's significantly weaker. The sun has a very loose grasp on those celestial bodies. It's basically just like debris. We actually don't know 100% sure that the Oort cloud is even there or what it contains. It's not something we've actually seen, but mathematically they've been able to calculate, and it's generally accepted that it does exist. But like I said, the sun has a very loose grip on those things, and so something to keep in mind is even more mind-boggling to me is that this solar system, we're not stationary at all. It's moving and spinning and rotating around the center of our galaxy. And there are other solar systems and other suns and stars and celestial bodies that have their own gravitational weight. And once you get far enough onto the Oort cloud, those things can be affected by the other bodies that are passing by us. And so their gravitational pulls or force can actually knock some of the, I don't know what you call them, rocks and whatnot that are in the Oort cloud loose and send them flying towards us. And those are comets. That's where our comets come from. Most of them, they suspect, are coming from the Oort cloud. But even though that grip is weak, it's still a strong enough grip to keep that Oort cloud surrounding us and mostly intact. So that's our solar system. There's a little side tangent that I didn't really plan on talking about, but here we are. So here we have our sun, and as I said before in the last video, we're looking at something that is roughly 13.66 trillion pounds, and has a, oh, you know what? That's the Earth I'm looking at. I don't remember numbers all that well. It's got a mass of, I can't even read this number, 4.385 times 10 to the 30. It's huge. Let's just go with huge. And it's got a surface temperature of almost 6,000 degrees Kelvin, which is insanely hot. And then a mere 93 million miles away, we've got Earth. And the Earth, as you probably already know, revolves around the sun in a counterclockwise direction. However, the thing about nature in general, and certainly these celestial bodies, is nothing is constant. All this stuff is very dynamic. Nothing's perfect. Robots aren't making these things. You know, this is just a matter of various forces pushing and pulling and ripping things apart and colliding and forming this stuff. So it's not moving in a perfect circle if we're looking at it from the top. It also, if you look at it from the side, it's not moving across the sun like at a perfectly perpendicular line like this. It's moving around like, you know, kind of that type of number and that type of number, and, you know, maybe not that extreme, but it's moving in not perfect circles, not perfect lines. And even within that line, like say if it's going that kind of angle, it's doing this kind of thing. It's kind of wobbling across it. And that's how we get all these different variances. The sun's doing the same thing. It's moving and nothing is constant or regular. It's all random and chaotic ball of gases and fires and electromagnetic forces. Likewise, the Earth is, if we're looking at this from the side, let's say, and that's its axis where it's spinning, it's not spinning on a perfect perpendicular line. Like I said, nothing's perfect here. It's actually tilted about 66 degrees, and I'm guessing on that. So if we're looking at 66 degrees, so that's a 90-degree angle. That's 45. If I were to divide this into thirds, I'd say that was about 60 degrees. And I didn't read anything to confirm this, but I would imagine that that's probably not constant either. It probably wobbles. You know, maybe it goes from like 67, 62. It's probably wobbling on that as well. And that's how we get all these variances in temperature and activity and everything else. So if we're looking at this, try to enjoy all those, ignore all those light-colored squiggles, and we have the Earth here. This part that is away from the sun is going to be dark, right? So now we have day and we have night, and North America could be up here, it could be down there. And as it revolves around the sun, and this is probably a review to many of you if you learned this in elementary school, the axis stays constant. It's spinning across this axis like so. But the axis stays fairly constant that way. Let's see, this way, we'd be seeing the back of it, so that's going to be all dark. Right. And this one would be dark over here. And then over here, it's going to be all light. But this is staying the same. And so we're getting direct radiation and whatnot here at our North Pole, South Pole, North Pole, South Pole, North Pole, South Pole, right? And this is how we get our seasons. So in the northern hemisphere, it's going to be right about here, going across the equator, roughly. This is getting basically a direct shot of light and heat, so it's going to be warm and they're going to experience summer. Whereas they are tilted quite a bit a ways, even over on this side, whether it's night or day. This is going to be a significant amount of distance. It's not huge in the grand scale of things, but it's enough to drop the temperature, 20, 30 degrees. And that's all it takes to bring us from summer to winter. It's a very small window of tolerance that we have to be able to survive, if you think about it. If you're looking at your thermometer, we're only comfortable, even the most chilly loving weather of us, say 60 degrees up to 90. That's our comfort level. I mean, that's it. You get outside of that survivability, even at 90, people can start having heat strokes. And if you're wet around 50 degrees or so, you can start suffering from hypothermia. Any lower than that, and this is without any type of accommodations, without clothing, without air conditioning or anything but what you're born with. Outside of these temperatures, you're going to have a hard time. Some people, even smaller. Personally, I don't like things to get anywhere close to, I like 75 is where I cap my comfort levels. So this bit of difference here is going to be enough to make that change in temperature for the seasons. And then when you get over here, it's reversed. The southern hemisphere is getting more of that direct shot of light and radiation, and we're left in the dark, and now we're having winter. If you're in the north, if you're in the south, it's summer. Good for you. And then here you have, they're kind of balanced out. If you look at on this side, everybody's kind of sort of equal here. So these transitional periods is where we're going from summer to winter in this way. So that's going to be fall or either spring, I suppose. And this side's going to be spring. That's pretty basic. But here's some numbers because I do like getting the grandeur of this stuff. How fast are we going? So the Earth is spinning on its axis. Got a rotation. Anybody guess how fast this thing's going? It is 1,000 miles per hour. Or wait. Yeah, that's right. I thought I read it wrong. And that equals about 460 meters per second, if you prefer that. So that's how fast it's spinning. And then if we're looking at just like how fast it's traveling, I guess it's revolution, it is going about 67,000 miles per hour or 30,000 meters per second. That's pretty fast. That's pretty fast. So we're in constant motion. We're spinning this way, we're revolving this way, and then on top of it, our whole solar system is moving, and then our galaxy is moving, and everything's moving. And it's not moving constantly, it's moving, wobbling up and down all over the place. Isn't that amazing? Why don't we feel it? We don't feel it because it's all pretty constant. So if you're in a car and you're driving, when you're accelerating, that's when you feel, or if you're on an airplane, when it's first taken off, that's where you feel it more extremely, is you can feel you get pushed back into your seat. And it's like, as it's going. But once you hit elevation and once it hits speed, now you can get up, walk around, everything's moving at the same speed. We don't feel it anymore. And then once it's time to land and it slows down, now you're lurching forward as it's starting to slow down. And so you feel that again. So it's the acceleration, the change in speeds that we feel. And I imagine this probably isn't constant either. I think I read that everything is very, very, very slowly slowing down and expanding and moving further and further away and all that. But it's at such a slow speed, that change, that we don't feel it. let's see, what else do I have here? Just about things not being constant. So you may have heard, I can't remember. Well, I didn't say it. I guess I wouldn't remember. I don't know what you may know. But you may have learned in elementary school or whatever that aside from all this stuff, I should mention this axis, this is what we call the geographic, or geographic poles. So that's where north and south, how we define things up. And here's put the equator. But aside from that, the Earth is not a perfect sphere either. It bulges at the equator, and it's a little bit flat at the poles. So one of many things that is not regular. Something else that I want to get to, and you know what, we're at about 16 minutes already. So maybe that will be it for this one. I will add one more thing. The moon. We forgot about our little buddy, the moon. Let me erase this. Well, we're talking about things being irregular. The moon was, what was it? 240, I think it was. Yeah, about 240,000 miles away from us. It is also spinning, and it's also revolving around us in the same way that we are revolving around the sun. And like us, it's not moving at a constant. It's moving kind of at different angles, roughly flat, but not really. And it's moving along an ellipse. And sometimes the moon is closer to us, and sometimes it's further than us. And that has a really big impact on us. I shouldn't say really big, but it does have an impact on us. Where this moon is and how close it is, that's where we get some fun stuff happening, like with the tides. And that's going to be in a different video for sure. But I figured I might as well give a little, what do you call it? Foreshadowing of that, of what is to come. All right. It's 10:01 a.m. I think we'll end it here. This, I think, was hopefully review for a lot of you. Refresher if you have forgotten, because, a lot of times, once you get past third grade, you don't really talk about this stuff very much after that. And so we're going to be coming back to these poles for sure. There's some crazy irregularities that happen here. And we're going to talk about this moon and the tidal system. And that's going to be coming up very soon. So like and subscribe, hit that notification bell if you want to learn about all that. And thanks for watching.